Hey guys, we're gonna be trying something new now. I want to try a video format. I want to try a video format where I go over blog posts and I talk to them and I share my thoughts on the blog posts with you. For the first episode of this series, we have an announcement by Databricks. This is not a sponsored video or anything like that. I just have had this announcement on my mind for a while and I want to talk to it. So let's just get into it. So this is the blog post that announces the general availability of Zerobus Ingest, the so-called almost Kafka killer by Databricks. This was published on February 23rd, as you can see here. That's almost, like 3 weeks ago. And let's just get into it. So it says, announcing general availability of Zerobus Ingest. Stream 10 gigabytes per second to your lakehouse in under 5 seconds with zero infrastructure overhead. And the first thing we should look at, I think we should look at the picture here that's attached. We have Zerobus Ingest. It's part of something called Lakeflow Connect. And on the left, you see all sorts of producer apps that are allegedly publishing data to this Zerobus ingest layer that goes into basically a Delta Lake table. So a Delta table with files that Parquet. There's an iceberg logo here, so I assume you can write in iceberg too, and all that goes through the Unity catalog. And the main things it says here is it's high throughput, it's near real time, keyword near, and it's low TCO, just like everybody else says. So let's get into the announcement. We're gonna read through the marketing hype here, look at the documentation and stuff, and basically see what sort of thing they announced. So the summary we have here is Zerobus Ingest is now generally available, provides a fully managed serverless offering. That's a good thing to point out. So I assume it to be something like a URL which you just produce data to. That streams data directly into Delta tables, eliminating the need for intermediate message buses like Kafka. Now that's quite the claim, eliminating the need for it. But from what I understand from this sentence is it's just like an API where you write into Delta tables. They did announce this back in the day. Let me see if I can Zerobus announcement Databricks. They did announce this, I think it was a year ago almost. I think it might have been this or this. I think it was in July. So it must have been this. Zerobus in July 2025. Here they call it the direct write API actually. That simplifies ingestion for IoT, clickstream, telemetry, and other similar use cases. So if we go down here, we made an exciting announcement introducing Zerobus, a new innovative approach for publishing event data directly to your lakehouse by bringing you closer to the data source. Eliminating data hops and operational burden enables high throughput, direct writes, low latency, yada yada yada. Previously, some organizations used message buses like Kafka as transport layers to the lakehouse. Kafka offers a durable, low latency way for data producers to send data, and it's a popular choice when writing to multiple sinks, which is entirely correct. One of the big things about Kafka is you can write to multiple sinks, and Kafka is an intermediate message buffer in between your data source and all those sinks. But of course, that adds complexity and cost, as they say, and that's true. And here they just want to basically hop over it. They don't want you to have Kafka. If you're going to write to a lakehouse, might as well just write to the lakehouse and not anywhere else. So the way I conceptually see Databus sort of in the picture is where you don't need Kafka, actually. If you're writing to only one place, if your data should be going to only one sink, which is the lakehouse, then you don't really need a Kafka there, apart from just acting as a temporary buffer for your data in case something goes down, etc. Now, the thing with writing to a lakehouse is that you cannot write in real time to a lakehouse because the way the tables are meant to be there, you're meant to be writing in big batches. I think the Parquet recommendation, let's see if we can ask ChatGPT for this. I think the Parquet recommendation for a data file was around 256 megabytes. So what's the default Parquet file that one ought to have in Iceberg, in an Iceberg table? What's the default? I think that the best is basically 256 megabytes. Let's see if this thing can, stupid ChatGPT, it can never actually do this. Let's try again. Look up the Iceberg documentation in depth and tell me the recommended Parquet file size in an Iceberg table. Let's see if it answers this time. But I remember it's 256 megabytes. I've looked into it back in the days. In any case, I'm just trying to say that you cannot stream your records in real time. Like every millisecond, you write a new record that's a few kilobytes in your Iceberg table, or Delta table for that matter. something needs to compact it, and you better batch it. So you better batch as much data as you can before you do the table write, because the table formats themselves are just not optimized for such low granularity writes. It's more of a batch thing. So here's what it found. It's to 512 megabytes as a default, as a recommendation. So anything below that would need to get compacted into larger files. And in any case, where I was going with this is that something like Zerobus could be doing that for you, which is, I think, very valuable, actually. Because if you do it with Kafka, you sit with Tableflow, you sit with all the things on market that write Kafka data to Iceberg. There is a batching step. And even Tableflow by Confluent, it's not like you write one record and it goes into the Iceberg table directly. No, there's a batching thing there. I think they use Flink under the hood. So allegedly, Flink in the background batches the topic data and writes big batches into the Iceberg table, which you can then sort of configure. So that's the complexity in Kafka if you want to achieve this with Kafka. And in open source in Kafka, I think you just have to use the Kafka connector, the Iceberg connector that's actually owned by Iceberg. So Apache, Iceberg, GitHub, they have the connector, if I'm not mistaken, somewhere here, somewhere in this repo. It's gonna take me a while to find this, I'm sorry. So why is there that Palantir folder? It's the first time I've seen something like this. Kafka Connect, yeah, the connector is here. I wonder where the README is. There was a README. Maybe I'm not looking at the right thing. But there was definitely a connector with a README of that connector. It was in another repo back in the day, but it got moved. Kafka connector Iceberg sync. It was in their documentation here. In any case, this is one of the only ways to write data to Iceberg from Kafka in an open source way. So these guys are basically promising you. Sorry, this is not Iceberg, this is Delta, but I think it's conceptually similar enough. Actually, I'm not sure if there is a connector for Delta. I haven't looked into it. In any case, I'm just trying to say that there is extra work to be done when you want to write to a open source, open table format from Kafka, and having that simplified, there is real value in that. So when they say it adds extra complexity and cost here, they are right. You have to manage a connector, figure that out, or you have to buy Tableflow from Confluent. That comes to an extra cost, and yada yada. So this sounds good. From a high level, it sounds good. So let's continue with the announcement. Okay, so it eliminates the need for an intermediate message bus like Kafka only if you only have a single sync target, which you shouldn't be even using Kafka if that's your target to begin with. You should not necessarily need a Kafka topic for this. The Kafka topics are meant to be read by multiple syncs. That's how it works. So teams can achieve sub 5-second latency. Now that's a big one, sub 5 seconds. So it's not really real time at all. This is the batching that I was sort of talking about. They cannot write in milliseconds. They have to perform some sort of buffering and batching. So this makes sense. While supporting thousands of concurrent clients and delivering up to 100 megabytes per second per connection for over 10 gigabytes a second of aggregate throughput to a single table. That's a big thing, actually. A single table, I think that's pretty good. 10 gigabytes a second of aggregate throughput to a single table, if you can achieve that. I'm not sure if the table needs to be partitioned or how that would work under the hood, but that sounds impressive. Up to 100 megabytes per connection. So this thing scales per connection, allegedly, that I read a little bit more into it. And thousands of clients also sounds pretty good. So, this is a marketing blog post, so take all of this with a grain of salt, but pretty good numbers. This GA launch includes production-ready gRPC API and REST APIs in beta, plus SDKs for Python, Java, Rust, Go, and TypeScript. This is pretty cool. So they're offering, 1, 2, 3, 4, 5, 6, 7 APIs to begin with. That's awesome. So they have 5 clients in the most major languages, Python, Java, Rust, Go, and TypeScript. They have a REST API that's in beta, apparently, and a gRPC API, which is also really cool. So this one thing I like about them. I think they're doing better than Kafka. They're just giving you everything ready in a box with all the APIs. Kafka today, I'm not aware of Kafka having a gRPC API, at least no mainstream sort of proxy that has this. We have a REST proxy, which Confluent offers, and you can host by yourself. And Kafka does have the Python, Java, Rust, Go, and TypeScript clients, although, they're not first-class clients, so the Java client is sort of first class, and the others are sort of lacking in features. They're always a little bit behind. But in any case, I like the widespread API support here. That's pretty cool. So let's get into a blog post now. We spent a lot of time talking before we even dive into it. So as organizations scale real-time operational intelligence, traditional streaming architectures have become costly bottlenecks. Managing message buses like Kafka and handling schema registries and connector frameworks creates a significant complexity tax that diverts high-value engineering resources from strategic business initiatives. Meanwhile, duplicate storage inflates cloud bills and multi-hop architectures delay critical insights. Finally, data in transit often sits outside centralized governance frameworks, creating compliance risks and lineage blind spots. Wow, that was a lot of jargon in the introductory sentence, but let's get all of this too. So first off, as organizations scale real-time operational intelligence, what do you even mean by operational intelligence? I always get sort of weirded out by these sentences. Operational intelligence to me, when you say the word operational, it means something like, let's say I click the subscribe button here, okay? And the system has to figure out immediately, okay, what email am I gonna send Stanislav? What do I know about him? How much can I personalize? That's operational in the sense that it has to happen in the millisecond I sort of click this, otherwise, I'm gonna get a weird email. So that's operational. But operational intelligence, I've never heard of somebody using a lakehouse to do something operational like this. So this sentence already doesn't make sense to me. I'm not really sure what I mean by that. And then they said traditional streaming architectures have become costly bottlenecks. And this again sounds very weird. I've never heard of a streaming architecture become the bottleneck. In fact, the narrative from the other side of the pond of the streaming vendors is that the batch architectures are the bottleneck, and they have been the bottleneck. So that's also very weird to say. But costly, I would agree. I mean, it is costly, but so is batch. I mean, all of these things cost a lot. Enterprise software costs a lot. So everybody just attacks everybody else's pricing. And unfortunately, both sides are right because both are pretty expensive. Managing message buses like Kafka has a complexity tax. And this I agree 100% with. This is pretty correct. When you manage Kafka, you have to deploy a schema registry, you have to think about how that's configured, you have to deploy the connect framework, and you have to find the connector that you deploy, and you have to think about configs of everything. Like the schema registry has a bunch of configs. The connect framework has a bunch of configs. The Kafka connector for Iceberg, just as an example, here's all the configs you have to think about and think through. It's not small. This is just one connector. So there is a real complexity tax that does divert engineering resources because somebody has to think through this and configure all this and work with this and understand it. And then they say that duplicate storage inflates cloud bills and multi-hop architectures delay critical insights. Now, I think this is complete bullshit. This multi-hop architecture delaying critical insights, I mean, you're saying basically that because you have multiple hops from like producer to Kafka to connector to your lakehouse is delaying critical insights, but then you say your latency is sub 5 milliseconds. I know very well that proxy architectures actually don't delay latency by more than single-digit milliseconds. So I think this is complete bullshit. And here we're talking about something on the order of 5,000 milliseconds. So this is just incorrect. But duplicate storage does inflate cloud bills, and that's true. To what extent is the real question here that we want to answer? The duplicate storage that they're referring to here is basically, you have something like when you store your data in Kafka as the intermediate message bus and then you write it to the lakehouse table, you're storing that data in two places. It's stored in the Kafka, in Kafka's own 3x replicated storage, and then it's stored in the lakehouse table, which is also somewhat replicated in S3 usually, and that costs something as well. So there is a duplicate storage cost here. I saved one link here that I want to go over. I did save it here, which is the BuffStream back in the day when they were marketing their own product. They were talking about the duplicate storage costs, and I think they were the first ones to talk about this. Let's see where it is exactly. But what BuffStream did is it had zero copy Iceberg tables, meaning you write your data to Kafka and it stores it in an Iceberg table format natively. And if you want to read from Kafka again, it's going to read from the Iceberg table. And they were marketing how cheap the storage was in that case, because again, you don't have to pay duplicate. And in their benchmark here, which again, grain of salt, it's a vendor benchmark, They said that the sharing storage with the data lake would save 3.5K out of something like 11K, I think was the total. Yeah, so 11 something. This is per month. If we get a calculator of it, because so, oh wow, oof, I need an ad blocker. Next time I'll install an ad blocker. Sorry about that. Bear with me with the ugly Bulgarian ads. So we got 31% decrease in the cost just from the duplicate storage. And what they're saying here basically is that if the storage has only one copy, you can attribute that to your data lake bill, let's say, and your Kafka cost sort of subtracts it. That's sort of what they're saying. Now, 30% of your Kafka costs going to duplicate storage, basically eliminating that. Not bad at all. I'm not exactly sure if they used tiered storage costs here or Kafka's 3x replicated storage, which is actually very expensive. I think they used the Kafka storage. So basically my take here is, while duplicate storage does inflate the cloud bill, in Kafka you usually store the data only for, let's say, a day or 2 or 3. So I don't think it really moves the needle that much. Whereas in the data lake, you store the data for potentially years. So again, I think that's sort of a marketing thing. So I'm gonna downgrade this from a yellow highlight to an orange one, because I still don't think it's that true. But it's true. You know, if you don't have to, it's true to an extent. If you don't have to store that much data, you don't have to store copies, that's good. Finally, data in transit often sits outside centralized governance frameworks, creating compliance risks and lineage blind spots. How I understand this sentence is, if you have a single pane to sort of manage governance, RBAC, and all these authorization and authentication schemes, which is you in Databricks, as you're probably a Databricks user, that's better than, you know, having, let's say, Confluent for your authentication authorization and then the same duplicate in Databricks. Whenever you have multiple places to manage governance, it gets trickier to keep them in sync, and that's kind of a risk. Well, we spent a lot of time just talking to the paragraph, but I promise the rest is gonna go faster. So, introducing Zerobus Ingest, near real-time streaming to the Lakehouse. Today we're excited to announce the general availability. It's part of Lake4 Connect, which we're going to go over. It's a fully managed serverless service that streams data directly into governed Delta tables, so no Iceberg for now, removing intermediate layers to deliver a simplified, high-performance architecture. By enabling data to flow directly from producers to the Lakehouse, Zerobus Ingest slashes costs and eliminates tool sprawl. That's true. It also delivers high performance at scale, supporting thousands of concurrent connections and achieving over 10 gigabytes a second of throughput to a single table in under 5 seconds. The single sync advantage, simplified architecture for major cost reduction. This kind of reads like a Gemini title blog post, by the way. I wonder if they used AI to write this. But the single sync advantage, let's see what it is. Traditional message buses like Kafka were designed as multi-sync architectures. That's super correct. Universal hubs that route data to dozens of independent consumers. However, this flexibility can come at a steep cost when your sole destination is the Lakehouse. Zerobus Ingest uses a fundamentally different approach with a single sync architecture optimized for a single job, pushing data directly to the Lakehouse. Nice. This architectural choice eliminates complexity and drastically reduces costs. No brokers to scale as your data volume grows, no partitions to tune for optimal performance, no consumer groups to monitor and debug, no cluster upgrades to plan and execute, and no specialized expertise such as Kafka is required on your team. This is very promising. This sounds very good, and I would agree with it. If you just want to put your data in the Lakehouse, having a custom-made API for it that's just focused on that and that doesn't have you manage all these general things that Kafka requires you to manage, sounds amazing. Sounds great. Obviously, you don't need consumer groups because you have no consumers. It's just in the Lakehouse, so there's nothing to consume it per se. You're just storing it directly in there, so that's nice. You don't necessarily need partitions because it's, I think, abstracting it away from you. You have no cluster upgrades because it's a managed service. That's awesome. There's no brokers because, again, it's a managed service, and no specialized expertise, again, because it's a managed service, and it's all just a single API, allegedly. With Zerobus Ingest, there's a single managed Databricks endpoint, just like I said. Create your table in the Unity catalog, start writing data with the API or SDK, and you're done. That's it. Oh, I hope so. Nothing else set up. The serverless architecture automatically scales up to support gigabytes per second without any config changes. And we have basically a dumb GIF here, or GIF of this. I don't want to look to it, to be honest. Zerobus Ingest simplifies the traditional streaming architecture from 5 managed systems down to 2 components, eliminating multiple failure points, reducing operational overhead, and removing the need for specialized expertise. Traditional architectures go from source systems to a Kafka cluster with a schema registry, 2 connectors, to Lakehouse. And here it's source systems to Zerobus to Lakehouse. Now, I don't see where the 5 systems are. Let me count them. Kafka is one system, schema registry is the second system, okay, and connectors are the third system. And here is just one. So really it's just bundling everything into one thing. And, but that's 3 to 1. I'm not, is my math wrong? They say down to 2 components. Well, the 2 components are the Zerobus Ingest and the Lakehouse 1, 2. And here it's 1, 2, 3, 4 components. So it's 4 to 2, actually. I'm not sure I see the 5. By eliminating the intermediate message bus, you remove 2 major cost centers, the compute and storage for the bus itself, and the dedicated engineering team needed to manage it. Now, we'll get to this again. Zerobus Ingest offers ingestion at a fraction of the cost per gigabyte compared to running and maintaining a self-managed Kafka cluster. Oof. I'm not sure if that's true. Zerobus Ingest offers ingestion at a fraction of the cost. Oh, they've repeated the same sentence here? Yeah, the same sentence is literally duplicated. So they're emphasizing the cost angle. Let's see the pricing. Let's see if the pricing is true. But it's true. I mean, it is important to know that if it's a serverless offering, they can just charge you per gigabyte. So you don't need to pay for compute and storage necessarily. But you would assume that that price is baked into the per gigabyte cost, which it probably is. It most probably is. Support interface and native integration. Developers can integrate via gRPC and REST APIs or use language-specific SDKs. Zerobus Ingest provides a broad set of push-based interfaces for industry-specific integrations, making it a flexible single tool that simplifies ingestion. We have a gRPC API, which is recommended for high-performance applications requiring the lowest latency and highest throughput. We have a REST API in beta. That's ideal for webhooks, serverless functions, and languages where gRPC support may be limited. We have SDKs, production-ready libraries, in those languages. And we have, so wait, the SDKs are using gRPC, it's just a wrapper on top of gRPC for those languages, that's cool. We have open telemetry. Bring your operational logs, metrics, and traces into the Lakehouse for long-term historical analysis with just a config change. Learn more about the open source, the open telemetry ecosystem here. This sounds pretty cool. I like this idea. You can see they've focused on the right thing, which is just increasing the breadth of supported clients immediately. And that really should be their goal. You should just make it as easy as possible to put data into your Lakehouse. It doesn't matter if it's a Python app, if it's an open telemetry, whatever, metrics reader, or if it's some language that just has a REST client, or if it's a gRPC. If you're using gRPC. So this is pretty cool. I like this. This is missing in Kafka. I've never heard of Kafka offering an open telemetry sort of endpoint or that type of data. SDKs are the Kafka clients, a REST API, Kafka has the REST proxy, and gRPC I haven't seen Kafka support. I haven't seen it support. I haven't seen anybody support it. So that's pretty cool. And them offering R4 in the general availability announcement, I think that's awesome. Also, since every write is governed by Unity Catalog, you get automatic lineage tracking and fine-grained access control from the moment the data is created, ensuring your streaming data has unified governance with the rest of your Lakehouse. That's also pretty cool. You get sort of audit logs, I would imagine, and lineage tracking and RBAC to figure out who created the data, what you can do with it, etc. And then we have apparently some customer testimonials, and we're almost done. Let's read through this. Again, pinch of salt. I hate customer testimonials because they're always just, I don't know, I don't trust them. Real-time manufacturing monitoring for Toyota Motor Corporation. Toyota sought a unified solution to instantly process telemetry from thousands of factory devices without the latency and complexity of traditional IoT architectures. Zerobus Ingest allows to detect overheating factory conditions in minutes rather than hours, directly supporting our carbon neutrality strategy and operational efficiency. But it's not just about tracking temperature telemetry. Having Zerobus Ingest as an additional data ingestion option gives us the ability to collect diverse factory data in near real time and trigger immediate countermeasures that have transformed our operations. This is interesting. So in minutes rather than hours, I wonder what the road system was. It seems like it was batch, and they just needed to move to streaming. But instead of actually moving to streaming, they chose to use Zerobus ingest, which could be fair. I mean, a lot of streaming companies will tell you need millisecond latency in real time, but if Zerobus ingest is offering something in, let's say, sub 5 millisecond latency, and your SLA or SLO is, let's say, a minute, or something, as I say here, minutes rather than hours, and that's how they need to detect overheating conditions, I think that's good enough. I mean, if your factory is overheating, do you need to know about it the second it happens or the minute it happens? Theoretically, you still need to call somebody on the phone in that factory, and that human needs to go down and actually manually, mechanically change stuff in the factory. So I'm not sure if 60 seconds make that much of a difference. But yeah, I like that 80-20 approach of, choosing the simplest solution for the job and not overly optimizing for milliseconds, shaving off milliseconds that you probably don't need to shave off. And yeah, as I say here, near real time seems enough for them. And that's still transform their operations. So I think that's the key takeaway here, is that even if you have batch, moving to near real time is 80% of the benefits for 20% of the complexity. That's sort of how I see it. And it's probably more than 80% of the benefits. It's probably 90% of the benefits, because just batch is so slow and hours take so long compared to like 2 minutes. Just like 2 minutes streaming. Instead of stitching together multiple cloud services, Toyota uses Zerobus ingest, integrate with global IoT connectivity from Soracom, that to mitigate the high maintenance cost of real-time operations, transform its manufacturing operations, and support its sustainability goals. So here we have some IoT devices going to some sort of cloud gateway of Soracom. Never heard these guys. To Zerobus ingest, goes to Databricks, and apparently there's stream processing here on a delta table. I'm also not sure what this means, but it goes to delta table. Let's say something like this. Izumi also explained that they are able to accelerate their operational efficiency when combined with Vista, their unified AI platform. Okay. And then some aviation company, accelerating flight performance analysis from days to minutes. An early adopter, they are streaming gigabytes of aircraft telemetry every minute directly to a lakehouse, enabling their engineering teams to analyze flight performance in near real time. There's some case study here. It reduced our telemetry resolution latency from days to minutes, allows our engineering teams to analyze flight performance in near real time, and accelerate our mission to transform operation. I think this is a fit here as well. If you have a aviation company and you have flights everywhere, and you want to provide, let's say, your internal team with some dashboard to open and analyze what the flights are doing and what they have done. Apparently they used the batch-based processing here, so they had days of latency and whatever. So getting it down to minutes is great. And if your only use case, and you're already a Databricks customer, and your only use case is to just chart this, I think a custom fit solution like ingest, like Zerobus ingest, is perfect for it. I think it's really perfect because you don't have to deal with all the complexity. Now, where Kafka would come here and where you would want to use Kafka is if you wanted to do more things, if you wanted to have programmatic responses from, let's say, aviation telemetry data. If you wanted to trigger some sort of automated task that does something when, I don't know, when the planes have been flying too much or they haven't been, I'm not really sure what you do with telemetry from aircrafts, but if you wanted to react in some way, then you would probably need Kafka, because you would have to have that thing happen in, I guess, more in real time, and also go to some custom program that you've wrote that reads this. Whereas with Zerobus, it's just going to a lakehouse and it's just going in a table. So it's not something you can really react to. I read it as something more for a human to sort of, query the data there when they have a need for it. Again, continuing on, powering industry use cases. Traditional infrastructure, I think batch-based infrastructure slows down real-time operations, of course, by removing the complexity of intermediate message buses. Zerobus ingest creates a direct sub-5-second path to value. It's not by eliminating the message buses. That's not the problem. The problem that slows down real-time operations is the fact that you're not using a real-time architecture. A real-time architecture doesn't slow down operations, it speeds them up. And Zerobus is slower than Kafka, and it's slower than basically any other sort of real-time bus you can use, so I don't think this is correct. Zerobus ingest integrates across industries. It's just industrial marketing. I never read this. Or should I read it? Well, actually, let's read it. Maybe I'm maybe I'm wrong here. Manufacturing, maximize factory floor efficiency. Use a Zerobus to build custom forwarding agents that stream massive sensor volumes to a lakehouse. This optimizes performance by eliminating heavy network infrastructure overhead. I'm not really sure what this means. Yeah, are they saying that because you're using the SDK, you don't have to stream the data over the wire from the machine itself and by some forwarding agent, I guess? And that eliminates the network infra? This went over my head. Telecommunications and IoT. Monitor global networks at scale. Deployed at the edge, Zerobus ingests pipes telemetry from your network to the lakehouse to track your network load in near real time. I assume the clients are deployed at the edge. And then they pipe the telemetry to Zerobus. Our partnership with Sorocom expands integration with secure, reliable global IoT data ingestion. Let's go back to the Sorocom thing. So apparently the Sorocom gateway basically has access to Zerobus directly. So there's some integration here. That's actually interesting if they have this partnership. I haven't seen any blog about this partnership, but that means they're actually going for IoT, which is very, very interesting if that's true. IT and cybersecurity. Identify threats without the ETL delay. Bypass complex pipelines by streaming logs and behavioral events directly to the lakehouse. This enables threat detection within seconds, adaptive model retraining, and faster instant response. Okay, just pipe your data in real time. Commerce and clickstream. Personalized experiences in near real time. Capture high volume clickstream data from apps and devices with minimal infrastructure overhead. This enables instant data availability to power personalization engines, A/B testing, and conversion optimization. So, this I don't get. What sort of personalization engine works on top of a lakehouse? I've never heard of this being the case. Personalization engines are usually custom made from what I understand. And A/B testing and conversion optimization. So you'd have to write it to your Delta Lake table, and then something will have to read this Delta Lake table and then power the data, the personalization on that. It really feels like they're trying to move these open table formats to operational use cases, which this is, I think, an operational use case. And I haven't seen enough examples of this. I'm not really sure. I don't believe this necessarily. Availability. Zerobus Ingest is now generally available on AWS and Microsoft Azure with Google Cloud coming soon. Pricing is volume-based. As part of the GA launch, there's a promotional pricing period. Yada yada. So let's look at pricing. If you remember, they said something here about pricing, which was that a fraction of the cost per gigabyte compared to running and maintaining a self-managed Kafka cluster. That they believed this so much they had to repeat it twice. So let's see if it's a fraction of the costs. Now, running and maintaining a self-managed Kafka cluster means you're maintaining it yourself. Think that I have a calculator for this, that I can calculate how much it costs. If we, let's say, if we're producing, so if we're writing to a lakehouse, would be writing 1 gigabyte a second, let's say, and we'd be reading 1 gigabyte a second. How much would be? We'd be storing the data, let's say, for 2 days, kind of, because the rest is going to a lakehouse. And this costs, let's say, on AWS, 2 million a year. 2 million a year. And it costs, let's say, 5.4K a day. Now that's 5.4K divided by 24 hours, divided by 60 minutes, divided by 60 seconds. We're getting to something that's around 6.3 cents a second. And their pricing here, I don't want this, seems to be 5 cents a gigabyte. So again, and this is just the infrastructure cost. If we're producing 1 gigabyte a second and consuming 1 gigabyte a second in AWS, without the optimizations enabled, this would cost us 6.6 cents, 0.3 a second. So it's basically 1 gigabyte a second, 6.3. And they're actually offering it as something that's lower. 5 cents a gigabyte, which is basically 5 cents a second if we're pushing 1 gigabyte a second, including the underlying compute costs. Wow, I'm surprised actually. If we there is something like a plan, so if we choose enterprise, it goes a little higher. It goes 6.4, which is more or less the same cost as what we had here. This is the price difference. But again, this is fully managed, whereas this is something you have to manage yourself. You have to deploy the cluster yourself. So there's a lot of extra cost here from a management perspective. So actually, this is fairly nicely priced, I believe, fairly well priced. Even if we compare to another serverless offering like Confluent Cloud Pricing, if we go on their prices, we'll see that their prices they vary greatly, which is problematic. But they charge you on data in and data out. And if you were using Confluent to write data to a Delta Lake table, you would have to pay both. Let's say you're doing 1 gigabyte a second. You have to pay 1 gigabyte to go into Confluent, then 1 gigabyte to go out of Confluent. And they have volume-based their pricing is really difficult to understand. It's really difficult. But as you can see, it's volume-based. I have to calculate how much a gigabyte a second is now. Okay, let's do it. 1 gigabyte for 60 seconds is 1 minute. For 60 minutes, for 24 hours is 1 day. For 31 days is 1 month. So you'd have, let's say, 2.6 gigabytes to terabytes. It's around 2,600 terabytes, I think, would be the total. Oh, but they count both, so ingress plus egress. So it would be 2.6, 5.3 terabytes would have a month here of volume. 5.3 goes into this tier, which would be, let's say, from 0.038 cents a gigabyte to 0.018 cents a gigabyte, depending if you use freight or enterprise or standard. And this is the price for ingestion and egress. So again, Confluent, let's write this out. Confluent Cloud, this is Zerobus, this is self-managed. So just the ingestion cost. So this is our cost, this is our cost, this is Confluent's ingestion cost. So if Confluent has, let's say, this like 0.038 cents, 3.8 cents a gigabyte versus 1.8 cents a gigabyte, we have to do this times 2 because you're ingesting and egressing. So this would be, let's say, 36, right? Yeah, 36 a gigabyte. And this would be 0.074 gigabyte. Did I get this right? Just double check. 76. Sorry, I suck at math. So depending on the Confluent Cloud tier, just the ingestion alone from Confluent may be twice the price of Zerobus or a little bit above, even depending on what you choose. But the thing with Confluent's pricing is also that they charge you for the storage. I'm not going to get into computing a full cost, but they charge you for the storage, they charge you for the compute. And I think all of this is basically going to be something that's close to equal to the cost of this, I believe. If not, maybe a little bit higher. Now, Confluent here has explicit discounts on volume. I don't know if these guys have discounts on volume. Maybe they do. Let's see how their pricing changes if you change the cloud. Seems to be more or less the same price. Azure doesn't have the enterprise option yet. In any case, so it seems competitively priced. I wouldn't say it's a fraction of the cost per gigabyte for running your own Kafka cluster, but it is certainly it seems competitive unless I'm missing something. Now, of course, here you have like TCO of people involved, and here it's allegedly not people involved, because it's a serverless thing. And in the Confluent Cloud, it's also allegedly not people involved, but here you have to manage a lot more because you're managing full Kafka, whereas here you're just managing a single API interface. So I kind of believe them that it's well priced. Now, the big caveat here with Databricks, this is sort of like the S3 pricing, like writing data to S3, is free of cost, of course, but that's what Amazon wants you to do. They want you to lock in your data with them so they can charge you a lot on everything else and on egress. So I'm not familiar enough with the rest of Databricks pricing, but I'm sure they charge a shit ton, to be honest. Excuse my language. So it makes sense that this is competitively priced to sort of attract users, attract data to their platforms. They can charge you more and more on it. But I would not say it's a fraction of the cost per se, though, but it's competitively priced, which is cool to see. So before we go, I had the documentation here of Zerobus, which has a little bit more information. I think it's written by somebody else, somebody more technical, I guess. It's less marketing-y. So let's see what the Zerobus ingest connector, they even call it a connector, what its limitations is. So it's part of the Lakeflow Connect, which we should look at Lakeflow Connect for a second. It's efficient data ingestion into your lakehouse. So this is basically, I guess, some sort of product to just dump data into your lakehouse, and you can create all sorts of ingestion pipelines that are all sort of, it feels like it's more vertically integrated than Kafka. So if Confluent is saying you something like a Kafka, it's a general sort of technical solution that you can connect to any sort of data source. These guys seem to be sending you point-to-point vertical connections that are easier to, I guess, set up and maintain, probably costlier. And I think they're only easier to maintain because they maintain it for you. But obviously, if you have like custom jobs, jobs from Salesforce to the Lakehouse, etc., and it's not a single architecture underneath, that in the long run, that should be more difficult to operate than just a Kafka. So I feel like there is a little bit of a gotcha here, which is, hey, use this like nice little interface to set up all these pipelines, and then before you know it, you reach Kafka's original problem, which was the pipeline explosion. Really, that was the main problem with Kafka. Let's see if I have the full thing here. Basically this, right? Kafka was meant to solve all of these pipelines here. Like you have one app connecting to one thing, to another, to another, to another. All of these are separate pipelines. The idea with Kafka is it simplifies all this because you just write to Kafka once and then you write to the other thing. Now here, Lakehouse will be part of these purple boxes. So you'll have a Lakehouse box here and you'll have Salesforce going to it. You'll have your app going to it, etc. But then nothing else solves all of the rest. And that's a problem for any architecture. And so that's why I'm saying don't be allured by the direct APIs and the direct pipelines, because before you know it, you're going to hit this problem again. So that's something to keep in mind. Okay, continuing on. Again, let's see what the limitations are. So latency reflects both the durability acknowledgement and the time to materialize records into a Delta table. Again, because this is something like a bus, you have the durability acknowledgement, meaning you write the data to Zerobus and it says, okay, the data is in Zerobus, and then it eventually gets batched and materialized into the Delta table. Now, time to durability, which is, you can look at this as the Kafka write. The P95 is less than 500 milliseconds and the P50 is 200 milliseconds. Well, that's pretty high. That's pretty high for a bus. 200 milliseconds of P50. Kafka can do something like 10 milliseconds, 5 milliseconds here. And the P95, I guess, at least is not that bad compared to the P50. Because a badly managed Kafka cluster can also go over 500. But yeah. But this is P95 actually, not P99. So another gotcha here, they don't have P99. Why don't you have P99? So it's probably pretty slow. Let's just take it at that. It's probably, if they don't include P99, it's probably really slow. Time to table also, no P99. So P95 is less than 30 seconds, which I guess is fair enough again, as you have to do batching and etc. It's a matter of cost. I think TableFlow by Confluent, last I looked at it, was 15 minutes time to table, but you could configure that and it just comes at a higher cost. Which, by the way, when we compared the Confluent pricing, we did not include TableFlow. I think TableFlow has additional pricing, so this is just Kafka versus Zerobus on the pricing that we compared, and this is no TableFlow or no table ingest, either custom made or extra price. So from that point of view, actually, Zerobus is probably cheaper if you want a serverless, zero management lakehouse sort of ingestion solution. All right, P50 is less than 5 seconds time to table. Now that sounds actually pretty good. That sounds pretty good. If in most cases you can write to Zerobus and it's in the table after 5 seconds, I think any data analyst will be happy with that. Throughput restrictions, 100 megabytes per second per stream. This is benchmarked with 1 kilobyte size messages. So that's one stream, meaning one client connected can do as much as 100 megabytes. That sounds pretty fair. 10 gigabytes a second per target table. Again, sounds very good. Like, that's super awesome. And then 15K records per second per stream. So this was benchmarked with 1 kilobyte size messages, which is 100 megabytes to kilobytes is 1000. Well, that's 100K records a second that they benchmarked here, but here they're saying the limitation is 15K records per second per stream. So actually it's 15 megabytes. At least according to the limits. I'm not sure how you would do I'm not sure how you would do 100 megabytes if you can only do, if it's benchmarked with 1 kilobyte, so they, whatever. I would assume this is more like a 15 megabyte type of thing. That's why I'm gonna strike it through here. It says 15 megabytes per stream, so I wonder what this means for this. Maybe we should, discount all these benchmarks by 90% or whatever. But it's still, even if it's 1 gigabyte per target table, if it's 50 megabytes per stream, that's still not low at all. That's still not low at all. Kafka partition, I would recommend it does like 5 megabytes a second. I mean, it could probably do more, but nevertheless, I think it's fine. To achieve maximum throughput, the client app and endpoint should be in the same geographic region. Of course, if you need higher throughput, contact our sales reps so they can sell you something. Delivery guarantee. The Zerobus ingest connector only provides at least once guarantees. So this is at least once, not at most once. It's good to know. It's good to know. There's no exactly once as well. I think that's pretty fair. The quotas are the default quotas for the connector. If you need higher performance, let us sell you more stuff. Why don't you contact support rather than the account rep? I'm not sure. The gRPC has 100 megabytes per second throughput per stream and 10 gigabytes aggregate, and the rest has 10k requests a second. So I read somewhere else that gRPC is the one that's meant for high throughput, and the rest is more for single messages or sort of less performance heavy applications. When writing to partition tables, the connector does not support writing to more than 1,000 partitions within a 5-second interval. So allegedly within 10 seconds, you can write to more than 1K partitions. That's a lot of partitions, by the way, for a single table. Or is this across tables? This might be across tables, actually, the way it's worded. So that might be a limitation. Someone needs to think more through this if they're going to adopt it. This is probably in aggregate. But then again, maybe it's a limit that can get improved as Zerobus matures. Catalog managed commits. Zerobus ingest does not support catalog managed commits. Do not use Zerobus ingest for delta tables with catalog managed commits enabled. Workspace and target table. The following workspace and target conditions are required. The connector supports writing only to manage delta tables. Writing to default storage is not supported, right? The connector does not support writing to storage secured to a private endpoint. That's interesting. Needs to be public. That might be a blocker for some people. The connector does not support recreating a target table. The connector supports table names with ASCII letters. Both the workspace and target table need to be in one of the available regions and both in the same region. Sure. There's a preview for liquid cluster tables, which honestly I don't even know what this is. When using Zerobus ingest connector with liquid tables, it's recommended to keep predictive yada yada. Compliance. Schema evolution is interesting. Zerobus ingest will never auto-evolve your target table. It supports continuous ingestion when nullable delta columns are added to the target table. So if you add a new nullable column to your table, it can continue ingesting. Missing columns are filled with no values, allowing you to send records with missing fields. This basically allows you to evolve your table, but it will never auto-evolve it. Supportable schema. As a record size limit, each message can be more than 10 megabytes. A record can also... This is 10 megabytes, right? Yeah, record size max is 10 megabytes. Headers take just 19, yada yada. Here you have all those types that are supported. I won't go through these. I found something more that I read here, but I'm not sure which table, which document this was in. Let's see if I have it here. It's the same thing? No. This is what I was looking at. So this is the connector preview. This is again the documentation of Zerobus. It's a push-based ingestion API that writes data directly into Unity catalog tables. Serverless connector. So this buffers transmit data before adding it to a delta table, as I thought. The buffering creates an efficient and durable ingestion mechanism that supports a high volume of clients. So it's something like a Kafka where you write the data to Zerobus and it gets stored there. And once materialized in delta format, the data becomes fully compatible with the rest of your platform, of course. So let's see how it works. The data producer first opens a stream to Zerobus and targets the delta table, constructs a message that matches its schema, and then pushes the message via the opened stream. The service makes the data durable, acknowledges the client's message, and materializes the data in the delta table in an optimized fashion. So here we go. Producer, open table, open stream to table, send the data, receive an acknowledgement, and the server does this. It retrieves the record, it serializes it, it validates the schema. This is pretty cool. It buffers, badges it, and optimizes it, and etc. Then it writes to Delta. At step 3, when it buffers it in its local storage, let's say, it acknowledges something back to a producer, then eventually commits to the Delta table. The stream is a direct connection between your client and the Zerobus ingest server. The SDK uses streams to facilitate long-lived high-throughput connections. Streams are only used in a gRPC API with the SDK, so only the gRPC API within the SDK apparently uses streams. A stream is to one target table. Event delivery ordering is guaranteed on the per stream level. So per stream, per client, you have ordering, similar to Kafka. If you have multiple streams per client, this probably gets trickier. Additional streams can be opened to write data to multiple tables. They can also increase client throughput, but if your client round robins messages to different streams, ordering will no longer be guaranteed, which makes sense. So it's only per stream. What does it mean if your client round robins messages to different streams? I think the ordering between the round robin messages will not be guaranteed, which is normal because each stream is its separate ordering. The Zerobus ingest server does not automatically create or manipulate tables. The users must create tables themselves. Tables and their schemas to the authoritative source. It accepts data sent to it by clients, validates, then writes to a table as we said. The server's responsibilities include schema validation of the message to a table. This is pretty cool. This implies that if the schema is invalid, it will reject it immediately, which Kafka does not do. It's the Kafka client that has to do that if it's configured properly, but it's way better. I wrote about this here back in the day, just like BuffStream does it. It's much better to have the validation directly on the server. And some of the newer Kafka, BuffStream does it, Tansu does it, I think Stream Native might do it as well, I'm not sure. But some of the newer Kafka forks or proprietary versions seem to opt for this, which I think is a great thing. It's interesting they're able to do this with 10 gigabytes a second of aggregate throughput, even 15 to 100 megabytes per stream, because deserializing and validating this is the part that takes performance away. And it's the reason why Kafka doesn't do it. If you have to deserialize every record and parse out of its schemas, if it's JSON or protobuf, etc., that uses CPU. So that's very impressive if they can do that. I wonder what part of schema validation this is, because there's two parts of schema validation. One is to just see that the schema kind of matches, and the other thing is to check if the actual fields are valid values. So something like BuffStream, for example, allows you to validate, I think they called it semantic validation. I think that was the word. I always get them confused. But basically, if there's an email field, they can actually do a regex type of validation that the string actually looks like an email and not like something else. Whereas schema validation is just, let me check if you have all the fields available for your schema. But nevertheless, both validations are valuable, and this is really cool. They support it. Then the server materializes the data in a timely manner. It sends acknowledgement to the client that the data is durable. Sure. The client selects a target table, establishes a stream, constructs a schema compatible message, of course, sends it, manages the acknowledgement, and has some recovery in terms of, if something fails. So, and this is something called durable fallback location. If a breaking change is made to your target table, after Zerobus ingest makes your data durable, but before it has a chance to publish it to a table, the connector will make the data available in a separate folder. So it's basically between steps 3 and 4 here. If you save data and it acts back, but then this schema changes here, obviously this write that writes to Delta will fail, and then instead of going to a table, they will write it to some sort of folder called table rejected parquets. So the rejected parquet files go there. So it's sort of like an automated dead letter queue that they have here, which I think is really useful and nice as well. Monitoring the cost, etc. And I think that's all we have, honestly. This was basically the whole announcement of Zerobus. So the takeaway here, from what I understand from spending 15 minutes on this now, is it's an API where you write your data, it goes directly to a lakehouse, is competitively priced, ingestion-wise at least, and it's probably just the best way to ingest data into your Delta table if you're using Databricks managed by them. It doesn't say here too much whether the table can be managed by you or by them, but I assume that it probably must be managed by them. I'm not too familiar with the deployment model of this lakehouse connecting, but I would assume it's managed by them, because also if they supported self-management, they would probably claim it here. I think that's something to market, but it's not being marketed here. Nevertheless, it seems like a nice feature, competitively priced. They're claiming high throughput. It's near real time. If you're storing to an open table format, I don't think you really benefit from having it be super real time in terms of have it in 100 milliseconds. If the P50, as they said, was with the P50 to get it to a table is under 5 seconds, and P95 is under 30 seconds, and P99 is like 1, 2, 3, 4, 5 minutes. I think that's good enough for any human querying it, because most of these are for humans querying it. And that's why I'm kind of confused about some of the marketing they had here that said, this enables threat detection within seconds in adaptive model retraining. How can you have threat detection within seconds if your time to table can be more than 30 seconds? If your P99 is probably minutes, that's not mentioned here. So I don't think this really enables that sort of thing. So any sort of programmatic reaction to this and programmatic thing that has to read the table and figure out what to do, I'm not really buying it. But for human querying the table, sounds pretty good. So anyway, I don't think I have anything more to say on this. So I'm going to close all these tabs. Thank you for listening to the first video I have of going through, some technical blog posts and some announcements. I may do more of these. This was a lot longer than I thought it was going to be. So we almost have an hour of a video here. If you had the patience to watch through this whole thing and found it interesting, please, comment and tell me what you liked and what you didn't like. Did I ramble too much? Did I talk too much? Would you like to just read a text format of this? I'm going to write some sort of copy on this as well, so you can read it under 2 minutes. But yeah, if you enjoy the commentary, if you want to see more, if you want to hear more, please just give me feedback, because that's the only way I can learn and do better for you and for everyone else. So yeah, thanks for watching, and yeah, see you next time.